Okay, let's do two more examples. Suppose you had a gas at 25 degrees Celsius and it has a pressure of 765 millimeters mercury and a volume of, let's say, 5.10 liters. Okay? If we hold the amount of gas and the temperature are held constant, what will the volume be if pressure is decreased to 742 millimeters mercury? Okay, so what are the what is changing here? So temperature is constant, the amount of gas is constant, so the only things that are changing is my pressure is changing and my volume is going to change, and we're going to look for this volume. Because of that, you know we're going to be using P1 V1 is equal to P2 V2, Boyle's law. And we're looking for the new volume. Okay? So let's list down what our values are. So P1 is equal to 765 millimeters mercury. V1 is equal to 5.10 liters. P2 is 742 millimeters mercury, and we are looking for V2. Okay, so now that we have all our values, let's go ahead and plug in and play. So if we do that, let's just rewrite our Boyle's law to solve for V2. So I'm going to divide both sides by P2. So V2 is equal to P1 V1 over P2. That's the same as saying 765 millimeters mercury times 5.10 liter divided by 742 millimeters mercury. And so what we get is 765 times 5.10 divided by 742. We get 5.26 liters is our new volume. And the question is, does this make sense? Since I'm actually just decreasing my pressure, then my volume is going to expand based on Boyle's law, that they are inversely proportional. So in that sense, because they decreased my pressure and my volume has increased, that makes perfectly good sense. Let's do one more example. Okay. Suppose you have a volatile substance, okay? So, you vaporize a volatile substance. You have the mass an unknown substance of mass 1.012 grams. the temperature at which you get the vaporization is 99 degrees Celsius. The pressure at a pressure of 742 torr. The volume of the flask is 354 cubic centimeters. Determine the molar mass of the unknown gas. Okay, so let's take a look. To do this, we'll need two things. One, molar mass, mu, is equal to the moles, no, mass divided by moles. Okay, we're looking for mu, and we have the mass, so this part's good. But we don't know how many moles of gas. So let's go, since we're talking about a gas, let's go to our ideal gas law. PV equals nRT. So if we know N, which is our moles of gas, then we can get mu. So let's take a look here. N is equal to PV over RT. Question is, do I have pressure? Yes. Do I have volume? Yes. R, that's a known constant, and T, I have that as well. So we can actually use this equation, our ideal gas law, get the moles of gas, and then plug it in here. So step 1, get the moles of gas. Step 2, then calculate our molar mass. Okay, so let's go ahead and do that. So to use the ideal gas law, we have to convert everything here. Okay, so now that we have this down, let's go ahead and do our conversions, and then I'll erase the rest. Okay, so pressure, that needs to be in atmospheres, and we know that 742 torr one atmosphere is 760 torr. 760 torr. So 742 divided by 760 gives us 0.976. It's three significant figures, 3 atmospheres. Okay, so our pressure is done. Temperature. Let's look at temperature. Temperature is in Celsius, but we need it in, that's right, Kelvin. So what we're going to do is we're going to add the 273. So 99 degrees Celsius plus my 273 is going to give me 372. Okay, so we took care of pressure and we took care of temperature. Now, let's take care of volume. The volume is 354 cubic centimeters. And we know that 1 cubic centimeter is the same as 1 milliliter. and we want it in liters, we know that 1,000 milliliters is 1 liter. Okay, so we can determine our volume. 354 times 1 divided by 1,000. We get 0.354 liters. Okay, so let's do 1 first. And we also know, let's not forget R. R is equal to 0.08206 liter atmospheres per mole Kelvin. Okay, so let's do step 1. Step 1, N is equal to PV over RT. Okay, that's going to be equal to 0.9763 atmospheres, it's 366, times the volume, 0.354 liters. Divide that by 0.08206 liter atmospheres per mole Kelvin. And that too is divided by our temperature, which is 372.15 Kelvin. Okay, and what we get for the number of moles is 0.9763 times 0.354 divided by 0.8206 divided by 372.15, and what we get is 0.0113 moles of gas. Okay, so let's do step 2. The molar mass is equal to the mass of my sample divided by the moles of my sample. And we said this was 1.022 grams, and the moles is 0.01132 moles. So we get 0.01132, and I get something like 89.4 grams per mole. So for an unknown gas, like what we're going to do in experiment 13, this is how you would approach calculating the molar mass of a gas. All right, thank you, and we'll move on to the next section.